Nice.
Wait, what? Good job. Kelsey, don't do that. Oh my god. You should. Yo, Shannon. Can you imagine if I
There's someone recording me.
I'm just gonna, block it. Why is it watching us? Whose camera is that?
That's my camera.
That's creepy.
It's a nice tripod.
I can't see.
It's already.
Alright, there's no bell. I don't know why there's no bell. We're starting class. I'm the bell. Ding. That's it.
What a beautiful bell.
That was a very good bell.
Mario, thank you for starting. I'm glad we were staying with the camp. Thank you, Alex. I'm getting to you. I see Sean. Thank you, Madison. Thank you, Nancy. Thank you, Isaiah. Thank you, Gloria. Get back to me when you figure it out.
Please, give it $1. Minus $1. What is that? In dollars. Oh, Jacob, only mine could be in the middle of that. No. follow. Is it right? 1, 2, 3, 1, 2.
Do you have question number 1? I would like to hear 2 different ways to do this problem. I want to say Josh's way for second. Let's say, Chelsea, what did you do? 3 minus 3. Five x is bigger than what? 38 minus 3. Loudly for everyone to hear.
35.
35.
So they divided
By what?
5.
When you get x, okay. Which one of these is greater than 7, Isaiah?
So complicated. Exactly.
So we solve the inequality, and then we look at the answer choices and we pick one. But this is a multiple choice question, so there's another way you could do this. Josh, what did you do?
Alright. Did plug in everything and see what's our answer.
What's one that you plugged in?
See.
Okay. So 5 times 7 plus 3
Equals 38, which is equal to.
equals 38, and we need to be greater than 38. So does C work?
No.
No.
So it's 8. I mean,
Okay, so then you try plugging in 8 plus 3. What do you get?
43, which is greater than.
That is greater than 38. Round of applause. So if it was a free response, of course, you wouldn't be able to do that because you wouldn't have anything to plug in and you'd have to go over here and solve it. But if you cannot remember how to solve, take numbers, plug them in, see if it's true. That's what you're looking for, solutions. Solutions are values that make the statement,
True.
yell it. True. True. You're trying to make the statement true. Now we want to try to make this statement true. There's a lot of stuff happening here. We're going to have to move some numbers around. We're going to have to move some variables around. Paul, what would you like to do?
I had 17 on both sides, which is 42. And I put 8 on the other side, -6. So I subtracted 8 on both
8
sides.
or 8x?
8x, and which is -14, greater or equal to 42. And then I divided -14 by 42.
Say that again?
I divided -14 by 42.
Yes.
Yeah. Oh wait, no. Because I did. Mark? Divided by negative. What? Yeah.
Divide by -14?
Yeah.
Okay. -14.
And I got x, and you have to reverse the sign, so
Very sneaky. Very
I
sneaky.
did -14.
So we have -14, we're dividing by -14, and because of that, we're gonna flip that sign.
And -3.
Oh. Jacob,
Can I do the graphing?
yeah. What number should we put in the middle?
No, I mean the number 3. The actual.
Oh, we're not there yet.
Done with
We're not done
it.
answering this.
Come on.
I just wanted to like exact
You wanna put your flag? Well, he called dibs on it, so,
Yeah.
so we'll go to him first. Melissa, help us graph the solution to this. Hold on a second.
Thank you, sir.
Welcome back. What number would you like to put in the middle? What are we gonna put over here?
On the left, I put -4, -5.
And
Then
over
on the
here?
right, -2, -1.
Okay. How are we gonna indicate that we're talking about x less than or equal to -3? Alex?
You put the shaded circle on top of -3, and then you make it go to the left,
And why are we going to the left?
because it's less than or equal to.
And now let's just ask ourselves a question. Should 0 be shaded?
No.
So if we took 0 and plugged it in over here, what is -6 times 0, Gloria? -6 times 0. 0. So we don't write anything. And then we still have -17. Melissa,
And then, 8 times 0, 0, so that'd be 25.
25, and the symbol looks like that. Is that statement true or false?
False.
False.
False. Definitely.
This is false, so should 0 be shaded?
No.
What do you think?
No, and
No.
also, you know, because 0 isn't, less than -3, and x should be less than -3.
This statement, plugging something in works. The reason, plugging in may seem kind of silly when we're doing number lines like this, where there's just one variable, and obviously it's saying that the variable is less than -3. But when we do more complicated things, like what we're gonna do a little bit later today, it's important to be able to pick a point and plug it in and check it. So that's why we're doing it here, even though it seems kind of trivial. And now, because he called dibs on it, Jacob, tell us what to do. Tell me.
Alright, so what I did first is I divided 2 and I did the same thing on the other side. Exactly. And then it was y equals 3 over 2x minus 3 minus 2.
Before we go over here, let's do some of these things we talked about previously when it comes to plotting lines. Sketch for yourself. Based on these numbers that you see here, is the line going to be going up or is the line going to be going down? Sean?
It's gonna be going up because it doesn't have a negative in it.
So what is the slope?
3 over 2.
3 over 2. What is the y-intercept, Shasid? How do we plot a line given these pieces of information that we have? Kelsey?
You put the y-intercept.
So I'm gonna go to -3, and now what do I do?
Plot the slope.
What is the slope telling us to do?
You go up 3 and -2.
3, 1, 2, 3, 1, 2. Or we go down 3. Yeah, keep going.
Down 3 over 2.
Down 3. 1, 2, 3, 1, 2. And then we just connect it. Every single spot where you see red color, red ink, every single spot on your page where you have pencil lead or you have ink, every single spot along here is a solution to this equation. If you were to take any one of these x and y values and plug them in, they would make that equation true. That's what it means to graph this. We have looked at solutions on a number line. Oh, before we do that, can someone read for us our aim, our goals, and our key terms for today? Nick, nice and loud.
What are all the ways to represent the solution to inequality? Variables also?
Yep, keep going.
I can translate between set notation, interval notation, and the number line. I can graph solutions for linear inequalities on the equation plane.
And tell us some key terms.
Inequality, less than, greater than, equal to, not equal to, number line, do, test point.
These are all the phrases that we're going to use today. So we've looked at number lines. We've looked at graphs of things on number lines. We've looked at statements of inequalities, graphs on number lines. The thing we've been writing so far, where we write like x is less than, x is greater than, things like that, those are called set notation, writing things in that way. So can someone tell me how to write this one in set notation? Ariel, what do you think?
You put braces in here? You put -1.
Could you say in words what this picture is saying? What values of x can, what can x be?
X could be a number below -1.
Yeah. So let's, I'm gonna leave off the braces. Let's just use math symbols to represent what you just said as a sentence.
Oh, 1, 2,
Oh,
Yeah, as an inequality, how would you write? Negative 1, x. How does x compare to negative 1? Less than or equal to. Okay. This is what we've been doing so far. There is, write things down. There is another way for us to write this. There's another way for us to take this picture, this statement, and write it in another kind of way. This other way is called interval notation. I'm going to show you some examples of interval notation, and then we're going to explain exactly how it works. So if I wanted to represent this in interval notation, this is what I would write. Like that. We'll explain what they all are. Let's do this one also. So if we wanted to write this as a math statement, similar to this math statement. Same kind of symbols. How are we going to write it? Alex?
X is greater than 2.
X is greater than 2. If I wanted to write that in interval notation, here's how I would do it. 2, infinity. Last one. As an inequality. Does anybody know how to write this? Melissa?
I think, I put -2 is less than x, and then x is less than or equal to what?
Yep. So x is all these numbers. In between -2, but not equal to it, because there's an open circle. And then it could be more than that, and more than that, and more than that, and more than that, and more than that. But when you get to 1, stop. You can be equal to 1. X is all those numbers in between there. If I want to write that in interval notation, we write it like this. -2, comma, 1, bracket.
Wait, that's square.
It is like a square bracket. So it looks like,
I'll do this over.
it's half. It's like that.
Oh, with the shape. There's like another line.
This is the number 1.
Oh. I thought it was a shape. Whoops.
So let's talk about these different representations and how to translate between them. So if we're on a number line and we want to include a value, what kind of symbol do we write? Let's look up here. If we are on a number line and we want to include the number, like right here we're including the number -1, what kind of symbol do we write? What do we write? Well, here we're including -1, here we're including 1.
Isn't it the less than?
On the number line. Ignore this, ignore. Just look at the number lines. What kind of symbol do you use to show that you're including the number? The dot, open or filled in? Let's say you want to include it.
For the first one,
Yeah.
then it would be shaded
Why is it shaded in?
because it's less than or equal to.
Or equal to. So if it could be equal to, then you're including it. So if you are including a value, then on the number line you shade it in. In our set kind of notation, you might use, what was that phrase you just said, Chelsea?
Well,
You just said for this.
less than.
Less than or equal to, or you might say greater than or equal to. And then in interval notation, you would put either this symbol or this symbol. Where? If you want to exclude, which means do not include, you do not want to include a point, what kind of symbol do you put by it? Yeah, you put an open circle. And in our set kind of notation, what kind of symbols might we use? Cam, what might we use?
Not equal to?
We could use not equal to. Let's keep them similar to this.
Oh,
Choose from those.
greater than or less than?
Yeah. And then in interval notation, you would put symbols that look like this, be just parentheses. So interval notation is just another way of talking about what numbers you want to include in your answer. So this is saying, let's start with this one. This one is saying, I want x to be any number that is less than or equal to -1. This is saying, start over at -infinity and go all the way up to -1 and then stop. Sometimes we put this parentheses, sometimes we put the square bracket. We put parentheses when we are not including a value. We put the square bracket when we are including a value. So this includes -1 and it does not include -infinity. The reason, can someone read us this note? Shannon, what does it say?
We can never actually reach -infinity or infinity, so we always use the symbols blank or blank in integral notation.
So we always use parentheses. You can never actually reach infinity. So you would never put a square bracket on the number infinity because it's not an actual number that you can touch or you can point to on the number. This one says, go to the number 2, don't include it. You can't be equal to 2. You cannot be equal to 2. You would start there, you would not include it, and then I want you to go everything past there all the way up to infinity. So you go to 2, you do not include it, and then you go all the way up to infinity. This one says, start at -2, don't include it, so parentheses, and then you go up, 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 and then when you get to 1, stop, and you do include it. So it's either include it with the brackets, or do not include it with the parentheses. Someone read for us this also note. Evo, read the also note.
Interval notation is completely different from x, y coordinates. They both use parentheses, but they are not related at all.
Not related whatsoever. This has nothing to do with x, comma, y. It uses the same kind of symbols. They are not related. Do not mix them up. Do not try to apply one to the other. They have nothing to do with each other. Let's take 1 minute for this think, pair, share. You're going to translate between representations by filling in the missing representations. So can someone just explain for us before we do this? In this first one, which kind of representation do we have? Sean.
What do you mean by representation?
So we have three representations. This, and this.
Okay, so I guess for the set.
Which one do we, which piece of information have we been given in this one?
The set.
This is blank.
Oh, I mean, the number line?
Yeah, we were given the number lines. You're gonna fill in set notation and interval notation. On this one, which piece of information have we been given? Jacob. Set notation. You're gonna fill in the number line, you're gonna fill in the interval. On this one, which piece of information have we been given? Interval. You're gonna fill in the set, fill in the number line. Take a minute on your own, completely on your own, try to do that. Take 2 minutes now, talk to the person next to you, compare what you have written.
Ooh, starting like
Let me pause you a second. If you have not copied down this block of information right here, I have no idea how you're even trying to answer any questions. This is the part that's telling you when you include a value, what it looks like on the number line, what it looks like in set notation, what it looks like in interval notation. When you do not include a value, what it looks like on the number line, what it looks like in set notation, what it looks like in interval notation. These are the three things you're translating between. If you don't have this written down right now, write it down, and then go back to figuring out the problem.
so over here. It's I just looked at it like, wow.
The infinity, it's just.
So it was put infinity one. Oh, the first one. Oh, yeah. So it's not.
So that.
All right, first one.
Oh, yeah.
Because it includes a number.
I did the first one. Can I do the third one?
You're not calling the shot.
Third one.
First one. Nick, can you tell us how to write this in the next representation?
X is less than or equal to -1.
Like that? Isaiah, what do you think?
Actually, I think it's X is less than or equal to regular one.
Good old regular one. If we wanted to write this in interval notation, how would we do it? Isaiah, what should we do?
The round bracket, negative infinity, comma 1, square bracket.
Can someone explain to us why Isaiah picked parentheses on the left, square bracket on the right? Jacob.
Because negative infinity just goes on forever, it's not actually a number, so it can't be like defined with a bracket. 1 is an actual number, it's regular, you know, so you can put a bracket on it.
Thank you.
Alyssa.
Oh, also on the number line, what is shaded in, so that we didn't include it.
Second one. We have this one representation. How are we going to draw it on the number line?
Oh, on the number line, it would be, an open circle and 0. And it's going to the right.
Do we agree?
Yes.
That's good. Interval notation. How are we going to write this in interval notation? Alma, what did you write? Why is Alma putting parentheses on everything?
Because 0 doesn't have a closed circle on it, so that's not included. And you never put closed parentheses around infinity.
Last one, we have the interval notation. Sam, how are we gonna write this on a number line?
Include yeah, like shaded negative 2
Shade in -2, okay.
and parallel.
Why are we going to the right? Madison. And why did we shade in that -2? Paul, why are we shading in -2?
Because it is equal to.
Yeah, which part of this is telling you that? Where are you getting that information?
The interval notation.
What's special about that symbol?
The negative?
The bracket.
Bracket, oh.
Yes. What does bracket tell you? Sounds phones. What does bracket tell you?
That's like where it starts and that's where it's equal to.
Yep, so it can be equal to. How about using less than, greater than, those kind of symbols? How are we gonna represent this one here? Vladimir.
X is greater than or equal to -2.
Great. 3 different representations. You have to be able to look at the picture, figure out these other 2 notations. Get one type of notation, figure out the other, make a picture, vice versa, move back and forth between them. You are gonna practice now for, there we go, 7 minutes. Do both sets of problems. Problem set 1, problem set 2, next 7 minutes. Can someone read for us the directions on each of them? James, directions on practice problem 1.
Nice. Graph. Graph is a division of a number line in bracket and interval notation. Stop.
Can someone translate those directions for us? What are you going to be doing right now? Josh.
We're gonna write out a number line and then select the group. Or it's gonna be
So you make a number line, and then what else are you doing?
interval notation.
What is interval notation?
Like the stuff with the like circle and parentheses and like bracket.
Parentheses, brackets, things like that.
No, the 8 side is. The infinite side. Oh, that's it. No.
Yeah.
Horizontally.
Bracket, bracket, infinity. And for the second one,
Yep.
what are you doing, Alyssa?
Graph the statement on a number line and write it as an inequality.
Gloria, what are we going to be doing in the second one? So what 2 things are you drawing?
What?
What does it mean to graph the statement? Number 1. And to write it as an inequality? What is that? What are you pointing at? Give me an example of one. Okay. X is less than or equal to. Sure, that's an example of an inequality. 7 minutes, practice problems. Talk to the person next to you when you have a question.
It's like shaded.
Yeah.
Now I'm gonna finish that one. I'd be like, no, it's details. Music was subtle. Good.
Oh, because I came away from juniors and look at that. Look at that. No, it's just look at to go from could do that dot dot dot.
Isaiah, tell them how to graph this one.
Oh, alright, so in the middle, you're going to have -2. It's gonna be an open circle, and it's gonna be going to the right.
How are we gonna write that in interval notation? Keep going.
Oh, so it's going to be round, parentheses, -2, comma, infinity, round parentheses.
Next one. Stacy.
Open circle, 6, the arrow pointing to the left. And was
Interval notation.
negative, no, parentheses, negative, infinity, and parentheses.
Let's just fill in one number on each side. If you wanted to fill in a number on each side of this one, what would we put? Paul?
On the right would be -3. Oh, left, my bad. And on the right would be -1.
And on this one, to see what do we put in?
7 on, right, and 5 on.
Next one. Sean, what are we doing here?
In the number line and notation.
Let's say, start with the number line.
Alright, you put -15 in the middle.
And what am I gonna put on the left?
-14. And then -16.
Like that?
And then you wanna, shade it in circle. And then arrow pointing to the left.
Evo?
I just use the number, the 14 and 16 to switch.
Agreed? How are we gonna write this in interval notation?
Oh,
Josh?
negative infinity. Oh, that's it. Less than, is greater than,
Interval notation.
oh,
Brackets, parentheses.
oh, that's parentheses.
What brackets is it?
Right.
Bracket. Tell me.
Oh, sorry. Then it is less than, JK. It's -15. Parentheses. Yeah, what's wrong? Just a joke, bro.
Ariel.
This is really only what Josh said, parentheses in the bracket should be
See, that's what I said, and then he gave me a look. I didn't know.
I'm sorry, I misdirected you with my luck.
Wait, how do you know if it's a negative,
I want everyone on that side of the room to hear this question.
Okay. Wait, who's asking you?
And I would like someone from that side of the room to answer it.
Sean.
Alright, so here's the deal. I wanna know, how do you know if it is a negative? Oh, negative. infinity.
Oh, I know.
Joe, can I ask a question? Joe, I am.
Did I pick on something?
Yes.
Because going on a number line, on a negative number line, going left is, that means it's gonna be infinity no matter what, but if you, oh, sorry. And if you go right, it has a chance of being positive. You're welcome. That's
Let's jump to one tricky one to do together. F. What weird thing is gonna happen in F? In F, Nick, tell us what to do.
you're gonna have to divide -7.
Okay? And then we get X.
Is greater than or equal to -2.
Two. Why did you flip the sign?
It was divided by -1.
So here's a number line. What number are we gonna put right in the middle of it? Madison, what should we put here? What goes over here? Over here. Are we gonna put a shaded in circle or an open circle? Chelsea? Shaded. Now are we gonna go to the left or to the right? Shannon?
To the right.
And now let's write this in interval notation. Alyssa, what should we write?
Brackets, -2, comma, infinity with parentheses.
Yep. Can someone explain for us or repeat, just so we're all clear, why are we putting a square bracket on the -2? Why are we putting a parentheses on the infinity? Well,
We put a square bracket on -2 because in the equation it is greater or less than, greater or equal to. So when it's equal to, you have to put a bracket next to the starting point on the number line. Or you have to like put it first in the formula and then put a bracket there.
and why are we putting a parentheses on infinity?
Because infinity is greater than -2.
It is. Can we ever get to infinity?
No.
You can never actually get there. You could never put a filled in circle on infinity. There's no place to put the circle. So you don't put a bracket. Let's do,
I have a question.
yeah,
Yes.
So how do you do, I didn't understand how to do E here. Thank you.
No.
let's do D. Jacob, tell us what to do. B.
Yeah. Alright, I got it. So the first.
Hold on a second.
Guys, shut up.
Hey.
Oh, whoa, whoa.
Oh, guys, please be quiet.
Here we go.
Alright, that's
What are we gonna do?
Okay, so first you minus 2 on both sides. And that equals -12.
Oh, that's it.
Yeah, and then negative.
Oh my. Thank you.
What numbers are we filling in on either side? James?
On the left is -13.
On the right?
There it is. 11.
Are we putting a filled in circle or an open circle on this one? Angelique, should we do filled in circle or open circle? And are we gonna go to the left or to the right? Here we go. Let's write it in interval notation. Sam, can you help us write it in interval notation? Negative what?
One. Wait. Oh, well, sorry.
Doesn't matter which number goes first.
Like, is this the same as that? Josh, can you channel Josh from 5 minutes ago?
Oh my gosh. 5 minutes ago.
And tell us about where negative infinity and positive infinity are located?
Oh, because it's on the left. And then, oh!
5 minutes ago.
Alright, sorry.
Are they the same?
No.
Not the same. That one, this one doesn't really make sense. It doesn't make sense to put the bigger number first. We read left to right, we read numbers left to right, we read pretty much everything left to right, so we want to read these statements from left to right. Let's do A, B, and then E. How are we filling this one out on a number line? Alyssa?
I put 3 in the middle, and then on the right is 4, and on the left is 2. And then I put an open circle on 3, and the arrow goes to the left.
If we want to write this as an inequality, how would we do that? Chelsea? Yep. How about this one? What is the difference between A and B? Kelsey, what's different? Yeah. This one has a parentheses. This one has a bracket. What does that mean? Vladimir. So here's 3, here's 4, here's 2. What are we going to do to that circle now? Angie, what should we do to this circle? Filled in or open? And are we going to move to the left or to the right? Why are we going to the left? Arrow.
Because x is less than 3.
Yeah. X, 3. What symbol are we putting in between here? Gloria, what symbol should we put here?
Or equal to.
Or equal to. Thank you. E. Here's a number line. What numbers do you think we should put on this number line? Nick, what would you like to put on?
2, 3, 4, 5, 6.
Let's go one more.
One more? Alright, 7.
7, okay. Where are we putting circles, filled in circles, open circles? Where are we going to put information on here? Nick, give us one of them.
Alright, so the open circle goes with the
Okay. And where does the shaded in circle go? Madison? And now where am I going to draw a line on here, Jacob?
I'm gonna draw between green.
And now I want to write this as an inequality. You spent your hand there.
That's why I got the other one.
Cynthia, can you help us figure out how to describe this as an inequality?
3 is
Let's set it up with some bookends. So 3 is on one end, what's on the other end? 6, and x is in between. So we just have to figure out what symbols to put. How does x compare to 3?
less than.
Here's 3, can it be 4? So is that less than or greater than?
Greater.
Greater. So we would say x is greater than 3, and also what else? Every English of it. Think about what symbol goes in there. Pam, what symbol should we put?
Is it, greater than or equal to?
Like that?
no, less, yeah, less than or equal to.
Less than. We start at 3, we don't actually hit 3, so we leave it open circle, less, x is greater than 3, not equal to, but x is less than or equal to 6, it can hit 6. We put this line, we put it filled in, because it was a square bracket, all these different representations. Do we need to copy this stuff?
I don't understand like
We gotta hurry up and do the next part.
Never mind.
We're gonna graph the solution to an inequality. Is this in the form where we would know how to graph it right now? If this was an equation, what would you like to do to this so that we could graph it, James?
I would like to do the equation
By 2. We end up with y greater than or equal to 3 halves x minus 3. Where did we see something very similar to this earlier today? Jacob?
On the warm up, we'll do now.
Do now. This is the same thing as the do now.
Wow.
If y was equal to this stuff, what would we draw? Ariel? Did you draw a dotted line for the do now?
No, you draw a solid line?
Solid line, yeah. So we go down to -3, we go up 3, over 2, up 3, over 2, up 3, over 2, down 3, over 2. And you'd make a line. But this is saying more than that. This is saying y is equal to it, and y can also be what?
Greater.
Josh?
Greater.
Greater. So it's this, but it's also this, and this, and this, and all the stuff
What?
over here. So you shade all of that in. The question is,
My mind is exploding.
the question is, should 0, 0 be shaded? Well, let's find out.
Yes.
Let's find out. If we take x is 0, y is 0, and we plug them in over here, we would have a statement that says 0 is greater than or equal to -6. Is that statement true or false? It's true. There's -6, there's 0, 0 is greater than -6, so 0, 0 should be shaded. Here it is, and it is shaded.
Oh my God.
Over here, is this in the format you would want it to be in order to graph it?
No,
No. What would you like to do to it, Isaiah?
you'd like to divide y instead?
We're gonna divide something, what should we do? We
I
want
mean,
to
divide 2, right, I'm sorry.
Divide 2, y less than 3 halves x minus 3. You treat this, you set it up exactly the same way you set everything up. You go down, when you're plotting lines, you go to -3, you go up 3 over 2, up 3 over 2, up 3 over 2, down 3 over 2. But here's the thing, can y actually be equal to this? Jacob?
No.
No, can't be equal. So Alyssa, what do you think we're gonna do?
Here is where you would do a dotted line because it's not included.
It does not include it, so we do not make a solid line. And now we're gonna say that y is, how does it compare to this? Is it greater than or is it less than? Alex? What does this statement here say?
Saying that y is less than 32.
Less than, so it's all of this stuff. If you plugged in a 0 here, you would have 0 less than -6. Is that statement true or false? Alex?
False.
False. So 0 should not be shaded in, and it is not, so that is good. So there are some parallels. Well, we just explained these, you can fill these in. When you have y greater than and y greater than or equal to, it means that y is greater or equal, so we shade in above. If you have these symbols, it means that it's less than, so we shade in below. So when we have these symbols here, do we use a solid line or a dashed line? Janet?
Solid.
We put a line like that. And this is similar to what symbol when we were plotting things on a number line. Jacob? Stuff we did during the do now and this last problem, sometimes we were indicating whether we include or do not include.
Oh, the bracket.
On the number line. Bracket, yes, but that's not on a number line. Here's a number line. Number
Oh,
line.
the shaded in dot?
Yeah. So this is similar to the shaded in dot. If you use either of these symbols, it means it can't be equal to it. So we use what symbol that Alyssa told us?
The not shaded in dot?
Yes. What symbols, what did we use over here on this one? Yes. Dotted line. And this is similar to what on the number line? Let's see a connection. Yeah.
The not shaded circle.
Can you explain the lines on the graph?
Everyone needs to be quiet though. Can you say your question nice and loud again?
Could you explain the lines that are on the graph going to the left and to the right?
So when we find the solution, we're finding all the values that make a statement true. When it was an equation, it was a line. We graphed a line because every point on this line would make that equation true. This is not an equation, this is an inequality. So this thing says y can be greater than or equal to 3/2 x minus 3. This line right here, is 3/2 x minus 3. And now my solution is that y is that solid line, and it's also everything greater than that. So I'm shading in everything that is above the line. Because it says it is greater than it. So greater, higher value, more than, above. This one says y is less than
So it's going the other way?
this stuff. So we shade in down, below. Can you summarize?
It's going greater than. You're going to shade everything that's greater than on the graph and vice versa.
We have about 5 minutes left.
Oh no, I can see that joke.
Pass it back. Please answer these individually. It is fine if you look at your notes, but do not talk to the person next to you. I want to know what you can do on your own.
What about my neighbor's notes? He just said.
Look at your notes. keep in mind, number two, this is an inequality, so you're gonna shade something in. You have to figure out which part of it is getting shaded in. Are you shading in above or are you shading in below?
What? What?
There's something wrong with it.
We still have. There's still another minute in your seat. Stop. Stay in your seat. We're not done. I will tell you when it is over. And ding, that's the bell. Take the exit tickets and put them on this table right here, please.